Welcome friends. Today we are going to meet a new technology, GraphQL. I'm Prasad and we have Samir to walk us through or introduce us to this new technology, GraphQL. So before going into the technology details, let's understand some background about this, why this technology is needed. So Samir, can you please quickly walk us through like why we need something like GraphQL?
Correct. Yeah, surely. I think it's a very different concept which came in a few years back, because of some very peculiar challenges which were faced, and the challenges were around the API layer, because when a front end like any JavaScripting based framework, when it communicates with the backend technologies, be them Node.js or Java or Python, there are certain peculiar challenges about the API calls that are made from the UI. Of course, REST is the de facto standard. So REST and JSON, that's the de facto standard for the APIs, right? But there are certain challenges. For example, typically, when you communicate with the backend to fetch the data to be shown in the UI, right, and that's your query. The model that you follow, while designing the REST, many times is governed by how you are designed the database. So your resource, as you define in the REST, the R in the REST is resource, right? That actually depends on the backend data model, and backend data model is inherently complex. It is built out of relationship. I think everybody who knows RDBMS would know those relationships. Those relationships can be visualized or imagined as a graph. For example, a book has an author, and author has many other books, and book has a ratings, and book has comments, and comments have comments. So you can imagine it will become more complicated as we go deeper. So when I'm showing my UI, I need to bring this data to the front end, and not just the book in this example. I need to bring the relationship as well to make the UI meaningful. That makes it complex, and that also makes it slow. So effectively, yeah, exactly. Because in a REST, you design a resource, your resource is book, and you have another resource called author and things like that, right? So that's the slowness. So that's point number one. Yeah. Second point is, there is a tighter client-server coupling which happens between your JavaScript and your backend code, because when you design the JSON which goes back and forth over the REST, you typically look at the backend data model and say, hey, here is the data that I have. So go ahead and build your UI based on that, or go ahead and build your API layer based on that. So API layer does not remain agnostic of data model. It actually gets a little bit tied down. And this starts causing further problems, because any small change in the backend data model means change in that JSON layer, means change in the REST APIs and whatnot. And that change percolates upwards toward your UI, JavaScript-based UI, right?
Yeah. So in fact, I think designing a good REST interface is also quite challenging, because I have seen both. Sometimes people include each and everything into one call, and sometimes they make it so granular that integrating at the client side becomes a tough challenge.
Tough challenge.
That's what it's.
Perfect. And that is really the third point, that typically, if you look at the UI, well, there is not a single UI nowadays. You have a UI which is browser-based UI. You have a UI which is mobile-based UI, and in mobile also you have Android and tablets. Let's say so Android iOS tablets versus normal mobile. So form factor.
Yeah,
then you have something like
smart
Alexa.
watches also.
Yeah, smart watches and Alexa and whatnot, right? Now, typically what happens is you start with the browser, and then when you move to the mobile, you realize, oh, I can't send so much data. Now, what do I do? So that's an overhead between the data model that you design. The worst case, you design API per UI, right? Which means to get a list of books.
That's one pattern which is followed. Yes.
One pattern which is actually followed, right or wrong, whatever it is. But it's also challenging. Imagine the maintenance overhead, right? So this again becomes another challenge. So that's the point number 3. And then there are many other things which we can look at later. How to optimize the reads, how to optimize your pagination, and pagination for your, based on form factor, pagination for mobile is different, pagination for your browser is different, and whatnot, right? So overall API layer design has been challenging, even though REST helps you in a lot. I think this was the real challenge, where need for ground up thinking has arisen basically a few years back. Yeah.
Okay, got it. So just to quickly summarize the challenges, I think what we have is we have different set of different client devices with different form factors, maybe different network challenges. And then if we have like only one sort of API which is going to suit all, then it could be a problem. So if I send too much amount of data, then it could be a problem. And also probably my patterns, like what I need to display, that may also change depending upon my form factor.
Yeah.
So somewhere that's where REST can really fall short in addressing those requirements. So I think that's what, just to summarize what I've understood.
Exactly.
Is that correct?
Exactly. Yeah.
Okay.
And a bit of a dynamism is needed in all this. That was, I
Yes,
think,
yes.
it was felt that way. So yeah.
Okay, fine. Perfect. So great. So I think with this background, can you just introduce us to our new technology, GraphQL, which will address this
Correct.
challenges?
Yeah, absolutely. So GraphQL, if you want to define in a very simple terms, which anybody can remember, GraphQL is a query language for APIs. Okay, very different definition, with a special twist to it, that it's a query language for APIs, which means I want to fetch data back and I want to design my API layer based on that. With a special thing that the request itself, which means the UI itself in the request, is describing the data that it needs. Okay, as part of the response. And backend, when it sends the response, it's dynamic in that sense, because it's basically whatever request asks for, those fields is what it sends back in the response. That's something to always remember. Yeah.
Something. So just to understand, so is it typically like our select statement from a table? I may select, there may be 10 columns, but I may select only 3 columns, and then somebody else may select 5 columns. Just trying
like
to
that.
understand.
And that's why that query language, I mean, sometimes it could confuse how can an API have a query language, but that's why it's query language. It's exactly like a select concept.
So that's the one flexibility which it's giving.
That gives you flexibility. Just the way select gives you flexibility, irrespective of what table structure that is there. You can fetch your columns. It's exactly like that.
Okay, great.
Yeah. But GraphQL doesn't stop there. I mean, it's definitely it's a query language, but it does more than that. I mean, there is a whole specification around it. So you can query, but there are also things called as mutations, which is basically you are trying to modify the data which is stored behind, which means creates and updates and deletes and all that. That is also supported. A reverse notification, which is like subscription, right? UI wants to know a particular data has changed. Even that is supported. Though in this particular session, I think let's focus on the query part, because that's the most interesting part.
Perfect. Yeah, got it. So about this particular new thing, about this GraphQL as a query language, which we can use sort of over an API. Does it use the same HTTP JSON, or is it something different actually?
Absolutely, because JSON has become the de facto standard, and there is fundamentally nothing wrong in JSON, right? JSON has the required flexibility. So yes, data model or data flows are via JSON, absolutely, and it is HTTP, and it runs over HTTP and HTTPS itself. Unlike say gRPC or any other protocols, which have become popular, but they have their own challenges. So this is typically HTTP friendly. Yeah.
Okay. So just to understand, so on the wire, probably it is very similar to what our REST call is, but it is much more on the top of that. So it's a one layer above what it is, what is really giving its features. Okay.
Yeah.
Fine. Yeah. Okay. So is there any background, like who developed it?
Exactly. There is an interesting background, because whatever challenges we talked about, right? These 3-4 challenges that we talked about is exactly what was faced by many people, but most importantly, Facebook, right? And when they were designing their Facebook wall UI for mobile devices, right? That time, they tried with the typical building HTML UI on mobile and all that, and it just didn't work because it faced all these problems. And that is when Facebook, the smart people in Facebook, realized that they need to rethink on the best practices of developing APIs, so that what a Facebook wall can show on a browser versus what a Facebook wall can show on a mobile, they had that flexibility and still no rewrites on the backend side, right? No double maintenance. That's where it originated, and Facebook went ahead. I think they developed it around 2012-13, and by 2015 they actually made it open source. So it's now available in open source. Yeah.
Okay, wonderful. So does it, as it is from Facebook, is there any good integration with React as well? Or, because that also has some origin.
Both are the babies coming out of Facebook. So absolutely. So down the line, I think by 2015 or 2015, I think they released a very clean integration between React and GraphQL via React with Relay. So by using Relay framework, you can actually integrate very well with GraphQL.
Okay, good. Fine, perfect. So I think we have understood what really a GraphQL is, and now Samir, can you just walk us through what are the typical high-level features, salient features of GraphQL as a technology?
Correct. Because it was designed to address those typical challenges that we talked about, right? I think the first one obviously was about the speed, because your speed reduces because you are sending too much data, irrespective of the UI. And to fetch complex data, I mean complex in the sense data stored at multiple locations, but it's related to each other, right? You have to make multiple calls, and who makes multiple calls? UI makes multiple calls. So there is a bit of a coordination logic in UI. Whether you write it in Angular or React doesn't matter.
Yeah,
To get
and it
rid
is
of that,
not simple. Yeah,
it is not simple because asynchronicity, you have to wait for it, and then all the data comes and all that, right? So we know that, I think, having done some UI development. So that is the challenge. So here what GraphQL tries to promise or tries to promote philosophy is, well, try to get it is through a single query. Whatever you need to populate your page, most of it, I would say 80% of it, try to get it using a single query. That's your using the GraphQL language essentially. And then that makes it very fast on the network. Because essentially, when you're making a query, and we will have examples flying by on the screen, when you make that query, let's say Amazon bookstore example, right? You are saying, get me all the books by author. So you are getting the books, you are getting the author name, which is stored somewhere in author. Who knows where it is? Maybe in a SQL database or RDBMS database. UI doesn't bother. You're also getting ratings, rankings, posts, whatnot, right? So all this complex stuff is left to the backend, but you're getting it in one call, ideally. That's how you are actually saving down. And again, a mobile may not need all the relationship, right? So mobile, we will say, well, get me just book name and author name only, or something like that, right? Which means it is saying I need only 3 fields. Browser is saying I need 20 fields with 3 levels of relationship. And that's the flexibility. Yeah, that's what makes it fast and optimally fast on the network based on what UI it is.
Yeah. So I think just to compare with the rest, so probably either I will end up getting all those 20 fields on mobile, or maybe end up doing different APIs. So that's where this will add a value to me.
Exactly, because the REST resource is book and REST resource is author. I'll have to make 2 calls, or REST resource is comments on a book. That's a third resource, right? If I follow the philosophy of REST, I'll have to make the third call, basically, right? And get that. So all that is saved.
Got it. And then because it is you are doing all that thing on the server, naturally, I'm not making those many connections and all that. So it is going to be
back
fast
and forth connections are not there. Exactly. And that saves on the network.
That's it. Yeah, perfect. But then one thing what I wanted to know, like, this is great actually. Like my challenges on the client are coming down. But then there are who defines those relationships actually, because there is a relationship between books and authors, and maybe typically in e-commerce, maybe even orders and so on and so forth.
Exactly.
Is there anything in GraphQL which addresses that actually?
Correct. No, valid question. Because now that we are trying to go enter into a zone of a complex model, REST by definition doesn't have any type system, right? It is defined by the backend developer, and it's maybe you have a wiki and Confluence and you agree on this is what goes in, this is what comes out. As against that, GraphQL ground up is designed with a robust type system. It is almost, you can say, strongly typed type system which is there. So both client and server are aware of what that type is. So I define a type like a book, I define a type like an author in this case, or if I'm e-commerce ordering system, then I define a product catalog, order and whatnot. So they're all strongly typed, you can say. Yeah. And all the relationship between these types are also defined within them. For example, we know, right? Book has an author, so there is a cross reference to author type, things like that. So, yeah, and we'll flash some examples also here, but yeah, that's what it is.
Okay, got it. So it's like typical, like I have a relationship or for either class type system or different types and how they are related, or maybe I can go to my table structure. So there are maybe 4 or 5 tables, and so at least that metadata is defined. So something similar to that we have in GraphQL as well. And then querying. Okay. And querying is done within those type system, is it?
Within those time system, yeah, because both UI, now it's like a contract, because we always say, right, API is a contract between 2 parties, consumer and producer. But now this gives you a system by which you can actually have a visible, verifiable contract. Verifiable in the sense, when I make a call from the UI side, from my JavaScripting to this API, there should be a way of verifying the structure of the request. Now, of course, my request may have 2 parameters or 5 parameters for the same get list of books, right? But those should be verifiable, or you should be able to validate against something, and that something is this type system. That's the point.
This type system.
Yeah.
Okay.
But I will also like to add one more thing while you are mentioning that so this is strongly typed system, etc. It needs its verification, etc. But when I'm designing it, when a UI developer and a backend developer are sitting together, there is no mandate on the UI developer to understand the underlying table structure or the internal complex object model. All he has to say is, this is the UX designer has given me this requirement, or my product developer has given me, my manager has given me this requirement. This is what I need. And then both the parties have to agree on that structure. So it's the process is expected to be a little different and not just borrow what your table structure is.
Table structure. Got it. Got it. So all the discussions will happen in terms of that contract, really, and then implementation is hidden probably on the server side, where a UI developer doesn't have to worry about it.
Correct.
Okay, got it. But does that mean that all my queries from the UI, but do they need to send all that entire data of that type system, or how? I got a little confused there. Or so basically, whether the entire book type I need to fetch it, or I can only select selected columns.
No, that's the beauty of it. That's the beauty of it. You are aware of that whole, how the book type is, but based on your form factor and within your UI where you are, you can decide what fields you need. So maybe in the list, when you're looking at a book, you just need 2 fields. But when I double click on it, I need 8 fields from the book, right? So that way, I can keep refining my, queries. And whether it's a browser versus, smartwatch or whatever, each one can make the same request, same API call, but say, give me a little bit less data, or give me a little bit more data, or give me an additional relationship because I can show bigger tables in my browser, things like that. So.
Okay, got it. So just to quickly summarize, so I can get, let's say, 10 fields about a book, but then I can select as a client, I can say, oh, I want only 2 for a time being. And then maybe some third field which is related, and then that GraphQL will return me only that.
Only that. So your response is fine-tuned to return only that. So it's optimized response.
So that's the power. So otherwise, probably in the rest, probably I would end up getting everything to that.
Correct.
Okay, got it. But then while getting this, another problem which as a UI developer I have come across is there any support for pagination, filtering, or anything of that sort?
Absolutely. Because we are talking about these kind of design where inherently there is pagination everywhere, right? So yes, and filtering also, right? Because when you're making query, even when we develop REST API calls, right, it's not always ID based, right? You pass a number of parameters and say, give me a range. So all these things you can easily do. You can specify the range. You can say, if it is a list, right? How much do I want? Top 5 or between this range to that range, ID between this, date between this and this, greater than this, less than, all those things you can do.
All that.
You can paginate, you can filter, you can, even for pagination, there are certain standard structures which can pass back and forth and communicate saying which page I am on and which one you want, all that. So that's very much, it's all built in.
I think that's quite powerful, because otherwise we will end up actually calling that REST API again and again, and then or probably design for that. So this is something like I'm firing a select query, like I can decide whether to get next set or not, and so on and so forth.
Yes, exactly.
But then with this, I'm just trying to understand as a developer. So do I need to, how much my dev process gets affected because of that? Because I think there are a lot of additional things which are there.
Correct. So, no, absolutely. All I will say is, I think it just introduces the next level of best practices, because now you're not just designing only UI or only backend database, you're also agreeing upon the API. So there is an initial work, like we said. I think 2 parties have to sit together and arrive at a type system which is mutually agreeable. And like we said, it's independent of database. The front-end developer doesn't have to worry what there is, but he needs to ensure that whatever information he or she needs is what he's getting to that type system. So it's a well understood type system. That's the extra work, I can say, basically, for both the developers.
For that,
as a part 1.
So maybe to begin with, you must have a better understanding into type system, their relationship, what I want. But later on, once it settles down, then the overall dev process productivity or speed will increase.
Speed will then increase, exactly. Then it will definitely increase. Because now, once you have defined that API, and once you have defined, what information needs to go back and forth, is it string or is it number or is it date? Now your client developers and server-side developers, they can actually kind of work independently. I mean, I know we are in the world of full-stack developer, but still, at any given point in time, maybe a developer plays one role or other, right? And that's where they can
absolutely
fly by independently, basically.
independently. Got it.
And then you have a contract to look at, in terms of API.
Great.
Yeah,
I think it's wonderful technology.
Yeah,
But
there's
as
one more thing also there, because now that you are doing independent development, changes do occur, right? So when a change occurs, maybe not in the first release, but maybe in the second release, and backend thinks, oh, I need to have a little bit more fields there, or user interface also feels we need to show a little bit more information there because we are capturing it somewhere else, whatever. There is a change. Now, traditionally, what we used to do is REST API and REST API versioning, right? So V1, V2, or V1.1, whatever it might be, right? And that was the best practice. Here, because we are going by the dynamic definition, so all you are doing is you are changing the type system little bit incrementally, right? And which is perfectly fine, because that change does not crash or collapse any existing UIs. The UIs which don't want to look at it, don't look at it, right? Because I'm specifying what I want in my query system. So I'm not forced to go into the version system of for my APIs. Of course, if you do drastic changes, you will have to do versioning, but for minor things, no versioning is needed. So that also escape a little bit. Your process remains a bit faster, I would say, release to release.
Absolutely. Well, I think that's very important.
Part.
Great. So I think we have quickly now understood what really GraphQL or what are its salient features. But I'm sure there are going to be some important things which we have to keep in mind before going to adopting this GraphQL technology. So anything specific you like to share with our viewers?
Sure. I think there are things to be remembered. But even before that, there is one more thing that I think we must know is what does a backend developer get, right? Because I have defined this API system. And a call comes in and says, give me like these 10 fields, right? And maybe from backend perspective, 5 fields are in one table, 5 in other, whatever it is, right? So the real question is there a help for a backend developer? And the answer is yes. Okay, so there is a thing beyond time system. There is a thing called as resolvers. Okay, and GraphQL API has a concept of resolvers, which means you can literally define per field, or for a bunch of fields, you can say what is a resolver. And resolver is nothing but a function. So if my implementation is Node.js implementation, then it's a Node.js function. If it is Java implementation, then it's a Java class function, that kind of thing. And so the GraphQL framework on the server side, there is also GraphQL framework on the server side, right? That's the implementation. That makes calls to the appropriate resolvers to gather the data, right? So you're actually gathering the data, formulating what you want, and sending it back. So the coordination job, which was in the front end in JavaScript, has now moved back, but the framework is helping you a little bit. So that's the important point, which I thought we should talk about.
I think that's interesting because let's say my authors, my books may be in one database, my author details may be somewhere else, maybe an API. So that relationship, somebody has to do that. So I think resolver can potentially do that. Got it. Okay. Cool. So coming back to my question, so what me as a developer needs to keep in mind before adopting this?
Exactly. Because even though this 2015 thing, this is still a relatively new thing in terms of adoption and all that. So we have to keep few things in mind, few learnings that we have seen in the industry. So one is this was designed to solve the problem of performance challenges by when you have related data and relationships and graphs, essentially. But if you have too complex a graph, which you are trying to get in one call, and you have then too much nesting of relationships, right? Book has authors, author has books, books has comments. So if you try to do too much, your query depth is too much. Your server is going to spend long time trying to gather that data, and you will actually have slower performance. So it will defeat what we started with, right? So that's something point number one to keep it in mind.
That is very important.
Exactly.
Somebody has to do the hard work. So if there's too much, then it is anyway going to be a problem.
Correct.
If not, client and server.
The balance has to be achieved. It's a typical design compromise that we do, right? That has to be done to use this effectively. Otherwise, you will use it to solve one problem, but you'll end up with the same problem. So
absolutely. So that trade-off is really very important.
Trade-off is very much important, right? So that's point number one. And then the point number two is we spoke about resolver, right? Which is nice feature, but resolver is from framework perspective, it is kind of blind to what you are doing, right? So if it finds, let's say, it has to get a list of books, 10 books, and each book has an author. It doesn't know that the author is same, right? So it's going to make 10 calls to you, and it's the same author. So are you going to go and get same author record 10 times? No, I mean, you don't want to, because then it will become again performance will wait. So you
Yeah.
need some batching and caching strategy in place. Now, GraphQL frameworks do have, like Facebook did release some piece of code and some references for batching caching, bulking caching, as they call it, right? It's there, but well, it's up to you. You need to have a solid caching strategy. Maybe you can use third-party, decent, or great third-party, caching tools or frameworks like Redis, Memcache, and whatnot. But that you need to have in place. Otherwise, again, you will suffer basically. So yeah.
Yeah, absolutely. And maybe I think probably one thing what now, please correct me if I've got it wrong, but probably it will also have impact on whatever caching one may have to do it at the CDN level or at the client browser level. I think probably there may be some impact there as well,
There will
because
be
I'm
some
moving
impact.
all that.
Yeah, because now you are moving all this to the backend essentially, right? And you are relying completely on the backend and not on the front end. Exactly. So it does have impact.
So that is something which one has to keep in mind.
Yeah.
Good. Yeah.
And then the third point is, I relate to the first point. If your schema is complex, type system that you have defined is complex, this is strongly typed, system, right? So there will be a parsing required and there will be a validation done, right? Which is by design. So because if I send some rubbish request and expect a response, things may fall apart, right? So there is a validation of your request and all that. But that's overhead, because if you make too many calls and in a very highly scaled system, many calls come in at rapid pace, there will be this overhead which could be in microseconds, but into thousands of requests per second. I think it's it will start mattering, right? So it's going to affect your server finally. So keep that in mind, right? Where to use it and where not to use it. This is
where not to use it.
Right.
Yeah. Perfect.
And,
so I think that's
and there is still one more point. Because we said, right, there is a resolver, but still backend has to do a lot of job. Finally, it has to figure out where to go and how to integrate with database, use the database, RDBMS or NoSQL or something else. This actually kind of, and GraphQL doesn't help you there. Basically, a backend developer has to still figure it out. This probably creates kind of, opportunity for some complementary, solutions or technologies. So I think there are technologies which are there, like Hasura as an example, or which is basically it gives you an ability to integrate or build the API layer GraphQL compliant and connect with different backend, right? And I think it's an interesting one. Will Prasad look at it in the next session probably. Or there are other special databases which are graph databases, all right, and they actually store the graph and they allow you to query the graph, like Neo4j, and they are also GraphQL compatible. So I think ecosystem has emerged, you can say, kind of. So that you have to keep in mind. These are the problems. These things could become a problem. How to get data from multiple places, and then you may have to look at some of these tools and techniques to be compliant or to be compatible with GraphQL. That's the last point.
Perfect. So I think very, very, very interesting technology. So just to quickly summarize, I think it's like a query language for the API. And then your client can decide what they want to query. Don't have to query each and everything to the client. Exactly. And then you need some work at the client side as well as at the server side. So definitely some work is needed as compared to REST. But overall, it helps a lot in terms of performance of the queries, the API queries, and so on and so forth.
Exactly. Yeah.
Great. So I think that's a wonderful technology. So thanks Samir for introducing us to GraphQL technology.
Thanks.
And friends, hope you have enjoyed this session. And then if you are not subscribed to our channel, please subscribe to our channel and hit the bell icon so that you will keep on getting the new videos which we are going to release almost every week. So thanks again for watching.
Thank you, friends. Bye.
Thanks. Bye.